then see how to import a 3D building in IFC format into a new file and design the VRF HVAC systems and ductwork systems in BIM. First, we open the program. We double-click on the openbim BOSCH icon, select the language and create a new file. We assign a name to the project and save it on our computer. This file is private and is not shared. Optionally, we can add a description. We then download the equipment from the online database and create a new BIM project in BIM Server Center. This allows us to store and share the 3D model of the building and the MEP systems, along with technical data. The project will be an empty folder for the time being. With the program open, we access the BIM Server Center platform to load the project. We see that the project is empty. From here, we can add the architecture IFC file that we have received by email, WeTransfer, or by any other means. In this case, we are going to include the IFC file received from an architect, generated with a program external to SIPE. To do this, we drag the file and the platform generates a GLTF required for the BIM project. We wait a minute for the IFC and GLTF to be generated correctly. Now we go back to the program and import it from the cloud. openbim BOSCH detects the spaces of the building, but not the thermal loads, so it offers the option of assigning them per square meter. We click Accept and the program assigns the thermal loads, classifying the architectural elements by type. This allows us to activate or deactivate the visibility of the types. The program also creates the floors. Now we'll place the cassettes. We don't need to choose the size, as the program automatically selects the most suitable ones, thanks to the thermal loads. Looking at the green cross, we place the cassettes in line with each other. Then, we place the pipes. If we leave the displacement box unchecked, the program detects the height of the equipment. Next, we bring the pipe to the utilities shaft. We go to the roof floor and insert the outdoor unit. If we activate the transparent model, we can see the utilities shaft underneath. By pressing the spacebar on the keyboard, we rotate the element. To create a vertical pipe connecting the two floors, the easiest way is to go to a 3D floor, deactivate the building model, and click on the 2 points to be connected without having to adjust the elevation. The program automatically generates the vertical and horizontal pipes to connect the points. If we click on Analyze, the program refreshes the analyses and displays any errors, but does not change the model of the equipment. If we select Design, the program assigns the thermal loads of the spaces to the corresponding equipment, and if necessary, adjusts the model of the equipment. By double-clicking on a device, we can see that the thermal load called Office 1 has been assigned to the unit and its value is greyed out, indicating that it cannot be edited. With the Modify Height Position tool, we can move the equipment vertically, either one by one or as a group. To access the diagram, we click on the corresponding option. Now we are going to enter a ducted indoor unit. We select the series and place it 2.2 meters above the floor. Once placed, we can rotate it with the spacebar. The program warns us that ducts are required. We enter the network and finish with the right button. If we forget to select the material, the program will inform us. We choose it in a section, and with the Copy Format tool, we apply the same selection to the rest of the ducts. The program then informs us that air terminals are missing. We select a diffuser, the smallest by default. When we move the cursor to the duct, the diffuser is automatically moved into position. The program displays warnings until the correct design is achieved. We join this equipment to the previously designed system. Then, with the Design tool, it assigns the thermal load to the indoor unit and creates the necessary duct connections. This thermal load appears in grey, although we can force another value if desired. The program informs us that the equipment does not cover the thermal load. An X appears in the tooltip to indicate this. We click on Design again, and the program automatically adjusts the model of the equipment to a larger one, and adapts the ducts accordingly. The diagram shows the new machine.